Probably get started here in about 10 minutes or so.
Quite a box there. What is that?
What is this guy doing?
White under the desk.
Yeah.
On the side. I got the white and black.
Dang, I have no idea what he is.
Looks like a beast.
Looks like what I'm planning to build next year.
Yeah.
Yeah.
You build systems.
If I need to, if I want a desktop, I do. I don't generally try to build a laptop.
Yeah, that's my opinion too. I'm not too bad with our systems, desktop systems. The laptops are kind of a pain in the rear.
I mean, I'll repair a laptop, but I won't build it from scratch. I mean, I have gone as far as replacing motherboards before, but so I might as well have built it, I guess.
Mirrors.
Oh shoot, now I have to get back to it.
How much storage can you get in Google for free?
I don't know, I've never run out.
They can turn on 11 gigs right now.
Good.
Still grandfathered in, we're at 5 months a year for
If anybody needs a Wi-Fi, add cows
Actually, no, it's kind of centered right here, so we'll stand here. Do you have a normal thing that you do at the beginning? This is your thing. I think you should introduce
All right,
it.
hey guys. So welcome to OST and Game Dev GR. Presentation time.
All right, presentation time.
So
Hey.
we'll tell you who it is.
Yes. New slide. Who dis? It's me. My name's Kevin G. Last name's actually Gerber, like the baby food, no relation. Sad. I'm this many days old. Okay, years, 2 to the 5th. That's 32 for anybody who doesn't want to do the math. Born here, and I kind of started when I was 10 to 12 years old with some basic, Visual Basic kind of stuff. And when I was 15, kind of decided I wanted to start getting into video game design and programming and things like that. And C++ was the language to do it with at the time, so I learned that. I play with a lot of game system prototypes, which is why I'm here today to tell you about character controllers, which is, had I gone to college, would probably have been like my thesis. And I also mix some music and sound effects and things like that, which I'm not going to be showing you today. So without further ado, we have character controllers. Now the type of character controllers that I'm going to be talking about today are all programmatic and focused mainly around first-person shooters and kind of physics systems and things like that. So normally you'd have things like walking, rolling character controllers, so like those rollerball games, driving, so cars and spaceships and planes and things like that, and personality controllers. I'm not going to be covering any of those things at the bottom. So what the character controller that I'm talking about isn't would be like a look, point, click interaction system. So like when you're walking around your spaceship and you see your displays and whatnot, the character controller is not necessarily what it is that's looking at it and saying, okay, I can interact with this. That's a different system. Weapon damage system, same deal. You still have a character controller that's represented by, you know, a physical volume of some kind that can get hit with things. But again, that's a separate system that's dealing with those. And then head bobbing and gun mounting, blah, 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 that kind of cool stuff, the stuff that makes it look really polished and nice. Like in Call of Duty, how you're running around and your gun's bobbing back and forth like this. I mean, that's just a procedural movement system that's just showing it right in front of your face. And has nothing basically to do with the character controller itself. So what their actual purpose is simply to control a character's movement and handle the interactions with the physical world. So breaking it down a little bit further, I'm covering the kinematic, dynamic, hybrid, and not the animation controllers. Any of you that are familiar with Unity 3D, there's Mechanim, which is more of an animation-driven control mechanism. That would be that last one down there. So kinematic, dynamic, and hybrid. Quick overview, kinematic is like just a direct move, doesn't use the physics system, anything like that. Dynamic does use the physics system, and then hybrid is kind of a combination of the two. So kinematic controllers, as you can see over there, I got Super Character Controller by Royston Ross. It's an asset available on the Unity 3D asset store. Really solid controller, but it is kinematic, so you can't do a lot of things like looking upside down. As kinematic controllers usually use capsule or elongated box shape. That's so that the bottom of it, and it's more often a box shape, and that's for dealing with stair stepping, which I'll show you in just a minute. The path trace, it actually takes that capsule shape or the box and draws rays from each of the corners of it or each of the primary points and casts it out into the direction that it's going to be moving. So you've got a character and it's walking around and you got some stairs in front of you. If you have that nice box, it'll run right into the corner. And then what do you do? Which I'll also describe here in just a moment. Like I said, the original procedural movement is kind of what I just described. Friction, so like starting moving is a consideration. So you have, let's say you're going to move at 5 units per second, but you don't want to get up to 5 units per second immediately because as soon as you hit, forward, you're blasting forward at 5 units per second, you want a nice gradual kind of acceleration there with a kinematic controller. Dynamic controllers, it works a little bit more naturally because it's using the physics system. Most often you've seen these kind of controllers in like Quake, Unreal, pretty much anything that uses PhysX or Bullet right now, unless they have some kind of special programming along with it. So like, excuse me, Unity 3D uses PhysX, and it has its built-in character controller, which is also kinematic. Some issues with it, caveats, little warnings, things that you run into. Artificial interactions with dynamic physics, sorry, you can read that. Artificial interactions with dynamic physics system objects. So when you're moving around with a kinematic controller and you're just sliding it through the world, you don't necessarily get realistic reactions from all of your physics simulated objects like balls and boxes and backpacks and whatever's falling around in your world. And then with this particular method, it uses additional ray casting, and that's just taking a point in space and then sending it out and seeing if it hits anything. And those are used for things like finding the stairs and can I vault over this thing and am I touching the ceiling? And so this is the actual sliding movement that the kinematic controllers, and almost all of them do exactly this process right here. If I'm not mistaken, this was kind of pioneered by id Software and John Carmack in particular. Might not have been, was it Billy? I forget the guy's name. I'm sorry. So we have starting to move all the way on the right there. We're going to move up and over the step. So we're going to move, and then we basically just have to assume that there's always going to be a step. So throughout that move, you also step up, and then you step back down. Then you apply the gravity. If you're actually touching any objects, this is where you do your simulated pushing and shoving and dragging and things like that. And then on platforms, this gets a little bit trickier depending on what systems you're using in addition to your character controller. It's kind of hard to keep one object on top of another object when it's not parented to the object itself. So if you imagine you have a hierarchy of like folders on a computer, but instead it's coordinates. So you have 0, 0, 0, and you can store something inside of that 0, 0, 0 and move that independently of it. And then moving the actual platform and keeping that stable, and it's rather difficult. And then, of course, the collision penetration correction. So when this moves, you do your move and cast it at a wall. That result isn't necessarily going to be exactly at the wall. It might be through the wall. And so then what your system, or what the physics system will do is say, okay, it's penetrating by this vector, so it's this far into your actual wall, and it will just correct it.
Was kinematic, because that was more mainstream, and now
Yes.
we start changing the dynamic?
Yeah, a little bit more in that direction. Kinematic, you have very direct control over what your character controller is doing, but it's more difficult to make it interact with the world necessarily how you want to, or depending on what your goals with it. And I'm definitely not saying that kinematic or dynamic or hybrid is better in all situations. It's really dependent on what it is that you want to do with your character controller. So now the dynamic controller, sorry, anyone else have questions? Okay. So these are usually and almost exclusively done with a capsule collision shape, and that's because of stair stepping. With this configuration, you don't usually do the same thing, that same slide move that you would do with a kinematic character controller. The dynamics controller is entirely controlled from the feedback of the dynamic system. So it uses that to read its environment, and then when it moves, you're actually adding forces to the controller or telling the physics system, I've moved this physics object from here to here, so I need you to do some calculations on that. Few little quirks about it. The edge case considerations, being stairs and opposing walls, are the two main things that I've run into. It's very weird trying to get stair step moving working correctly because it has a tendency to kind of hop since you're using a dynamic system. So, I don't have anything to throw. There we go. So, like the dynamic system, if I had my inhaler here, say this is the character controller, and it's just sliding across the screen, and you have the stairs here, it's going to have a tendency to want to like ramp up off the stairs. because of the actual physics simulation. It's trying to take into account the friction, the actual momentum of it, and angular velocities as well. And then we have hybrid controllers, and these are my favorite because they take concepts from both kinematic and dynamic controllers. You have, most often these are experimental, most often. They combine concepts from both of them, and really it's great not having quite the same volume of ray casting that you have to do with kinematic controllers, because you have an overabundance. Let's say you have 20 characters in the game, and if you're blasting out 8 rays for each of those characters for just one singular move, I mean 8 times 8, well, make 8, it's easier, not 10, 20, 64 ray casts in one frame just for that many characters. And let's say you want to scale that up to something more like, Destiny 2, for example. I mean, their servers are simultaneously running instances of hundreds, if not thousands, of players at one time. So ray casting considerations are very important. And of course, with the hybrid controllers, you still have some of the edge case considerations of the dynamic controllers because they do work so much more, well, literally dynamically. Some more comparison stuff, just for your perusal. This was more for our guests who are downloading the, and I'll get you a copy of that so you can. So hybrid controllers, kinematic hybrid, always based on kinematic controller concepts, so you're not defecting to the actual dynamic system, except for some very rare interaction type things. So like if you were to jump, a hybrid kinematic controller might use the kinematic process to walk along stairs and things, but as soon as you leave the ground, it's doing a physics simulation or something along those lines. And again, the overhead or the raycast overhead. Hybrid controllers are more dynamically simulated. Again, my favorite. They actually use in my experience, you actually use very few of the kinematic concepts. There's like, I think 1 or 2 things that I've done from kinematic concepts with the hybrid controller in order to make it step upstairs properly. And of course, more realistic interactions because you are using the physics system, and some low overhead because of the lack of additional ray casting. The nice thing about the dynamic system is that you're actually pulling in information. What was that? Oh. You're actually pulling in information from the simulation itself. So if you throw a ball in the simulation, that ball is going to hit something. You can take all the contact points from that and then determine, well, in this situation, it's more like, is it head space, is it body space, or is it foot space? So in our current physics system situation, part of the reason that some of these things are a little bit more difficult, let's say if you want to make a game like No Man's Sky, where you can fly around from planet to planet and you can get in and out of your spaceship, flip upside down, walk around the hull of it, things like that, it's going to be really difficult to do out of the box for pretty much any physics system currently because they have global Y for their character systems locked up. So no matter what you do, if you open up a copy of Unity 3D, pulled out the character controller, and then told it to rotate this way, it's not going to work right because it's expecting Y to be this way. So obviously making walls and ceilings is a little bit difficult, but here's the reason that they do that. A lot less mathematical calculations when you're not dealing with arbitrary rotations. And then the singular gravity variable, it really reduces the memory cost, because if you're keeping a floating point variable for every single one of your characters, then you've got that duplicated across every single one of your characters, every single one of your objects. And so it's a lot nicer, smaller memory footprint, and you don't have to recalculate the gravity every single time. And continuous collision just basically helps tunneling. This was just a point that I wanted to make that exists that I wasn't sure if everyone would know about. Any questions? Just some considerations for a lot of first-person style character controllers that you might have for your game. View manipulation, obviously HeadBob, and XR being the new term for virtual reality and augmented reality. It's just, I think it's probably extended reality or something. And then environmental considerations, relative gravity and buoyancy, so things floating and things actually gravity wells and stuff like that. Yeah, movement, airfoil. Different stances. Crouching, prone, and crawling are kind of interesting. You'll take your actual character collision representation and shrink it or expand it, which also takes considerations from the feedback system or your kinematic process. And then interactions. Again, like I mentioned, it's not necessarily built into your character controller, but it's probably paired with it in order to make it any kind of useful in a game situation. So climbing, vaulting, running and jumping. I mean, those are, or sorry, wall running and jumping. Those are kind of advanced features that you might expect a character controller to implement. Sitting and attaching, of course. So like if you want to get into the spaceship, and I have an example here that I'll be able to show you guys. And then item holding and use with weapons and equipment, as I'm sure all of you have seen rampantly across most genres of games. So that's it for the overview part of it and kind of the details portion, I guess. This is a system that I've put together using a lot of the concepts that I just ran by you guys, and I wanted to share it with you, answer questions, and see if you like it, I guess. So from that same list, I've implemented almost all of the things on that list for this particular library. So my procedure, a little bit different than the usual kinematic procedure. It actually takes the physics tick, so every time your physics is getting processed, it's, I think by default in Unity, it's like 20? Yeah, I think it's running, is it 20 hertz simulation or 10 hertz simulation, something like that. So every 1/10 of a second or 1/20th of a second, you have your physics tick happen. And then that gives me all of the data points for like, well, like I said earlier, running into the stairs or running into a wall. And I use that to calculate the surface of the ceiling, the wall, or the ground. And so basically, if it's touching around here, it's definitely a wall. If it's above this part, it's part of the ceiling. And if it's below, you know, however far down here, it's part of the floor. We can then apply forces based on which direction we want the character to move. So if I want to move forward and there's a step there, it's actually going to take my desired movement vector, which is forward oriented with the character, to that little incline that's made by that contact point at the top of the stairs and the contact point at the bottom of the stairs. So now we have a vector normal that's pointing in a different direction. We want to move this way, so we readjust it to go up the hill. And then we just clear the contact data and do the whole thing over again. 10 to 20 times a second, and it works surprisingly well. So this is just kind of a quick breakdown. I have, for any of you who are familiar with Unity 3D, to supplement to the rigid body class called Gravitally Influenced Rigid Body. Gravity Walkers is actually the bipedal character simulation that I've put together. Environments, or the Envirosphere and Gravisphere work kind of in tandem, where it's a volume that once you enter it, that's the environment you're in, so it automatically parents you to it, which prevents the problem of platforms and being able to walk around inside of a flying spaceship. And then the Phantom Rigid Body, this is quite honestly just kind of a hack, because the physics system wouldn't let me do this out of the box. I have to synchronize the actual rigid body with a fake rigid, or a fake structure, so it synchronizes like where the ship is, so I can do all the inside stuff on the ship, but the outside of the ship is represented just by a basic collision. So I'll be showing you guys my debug window, so you can see kind of some of my debug lines and kind of what's going on with the character controller itself. And then just because I have it, I'm going to use the Oculus for VR. So thanks for listening to my talk. I appreciate it. And without further additional ado, I will get the demo going. Okay, is this running? Are you running? No, you're not running. That is not my debug window. Hey, stop. No, stop. Thank you. Pardon me. Get up here. Alright, so you'll be able to see my view on the left here, and then debug is on the right. Let's see if I can get this in a good spot to kind of see what's going on. Okay. Right here we've got some water. First I'm going to show you the nice stair stepping. If you see on the right side there, looking at, yep, should be able to see some of the debug traces, white lines, red lines. That's what's representing the actual floor and recalculating which direction it's moving. We have water, which reacts accordingly. Sorry, the headset's freaking out a little bit. See this nice structure. Got a bunch of gravity volumes that are oriented along the stairs themselves. So we can just run up. Ah! Oh, it's being stupid. Like I said, it's experimental, so. Oh, we fell. Okay. Well, that's a platform that does work, so I'm just going to go for this more fun platform. Actually get into the spaceship.
Is that button game?
What's that?
Is that button game in the box?
No. All right. That's pretty much it for my my presentation. I hope you all got something out of it. And
I got a question.
yes.
So you're saying that line trace, when you're facing, let's say, the stairs on the wall, when that line trace looks at that stair, it reorients you, and that's how you're able to kind of almost walk upside down?
That is actually based upon the gravity volume. I'll show you that in just a second. So some of the stuff that you're not seeing behind the scenes
Or
here.
like, at what point does it like, hey, we need to switch your orientation to walk up?
See this box right here?
Yeah.
This green box is actually the gravity volume. So once you enter this box,
I see.
it says, okay, what's the gravity priority? So I have different priority values. And if it's higher than the character's current priority, then it'll use that gravity instead. The same for any of the environmental volumes. So you could be in one environmental volume, in one gravity volume, pass into a second environmental volume, but still use the same gravity, kind of a thing. So, whoop. Ah, that's not what I meant to do. Okay, that's all I've got for you guys. So.
Out of curiosity, how long did it take for you to come up with what you see here?
This is about the 7th revision of this system that I've been on. This incarnation somehow only took me a month and a half, but I attribute that to the idea that I've done it 6 times previously. Previous ones have taken me, I mean, all said and done, I've been working on this literally half my life. Just learning about character controllers and how they work, how they function, and how I can make them work how I want them to.
When you say you work on it, what do you work on it in? Are you doing it in C++ or C or?
I originally started off writing my own game engine. When I was 15, I went and set out to do C++ work and learning how to make a game engine. I came across the physics engine portion of it,
Okay.
and so that's kind of when it started. It was in C++ and working with the Bullet physics system.
So you created your own physics engine and you integrated it into Unity 3D?
No. I actually built my own game engine that's similar to Unity 3D. It's not nearly as mature, which is why I switched over to Unity. It was much easier. But I was using the Bullet physics library. It's actually what's integrated with a tool many people are familiar with called Blender. And Pixar actually uses it in their movies to do their physics simulations for things like falling candy and dust and things like that. So I had to go in, learn the bullet physics system, integrate that into my game engine, and then I built the character controller.
So what are some of the challenges that you're struggling with?
Thankfully, this last incarnation, I've gotten rid of most of those. Some of the challenges that I had run into were things like the stair stepping, like I mentioned several times. That was one of the hardest ones to get to feel right, because if you're going at a certain velocity, it doesn't have enough velocity to actually get up the steps, so you have to figure out when to supplement that based on this like arbitrary glob of points. Jumping, surprisingly, was actually kind of a more difficult thing for me to do, because I didn't want to put in jump with this much force. I wanted to say jump 2 meters. And so in order to do that with the physics system, you have to say, okay, 2 meters, calculus, this is how much force it is. And so there's that. And then one of the concepts that was really important in this particular design was the ability to actually go into a spaceship and walk around. It was baffling to me how anyone had actually achieved it, and come to find out, they fake it by using that same Y pinned up coordinates physics system. They just rotate the representation of it, basically. So your cameras are, it's all smoke and mirrors kind of trickery that's going on, instead of actually doing the math for it. So they're figuring out this way to do it, and I'm trying to figure out this way to do it. Challenges.
So where are you going to head next?
Well, right now I actually have a Patreon up with a bunch of my different projects, and I'm kind of leaving it up to my patrons to figure out which direction we're going with it. If it happens to be this project called Pod, it will be fully realized, and you'll be able to fly around in spaceships and go from planet to planet and things like that. Another project is called Royale. It's along the same vein as some of the newer Battle Royale games that are coming out, like PUBG and Fortnite and was it 7 Days to Die? No, H2Z2. H1Z1. H1Z1. And then there's a couple of projects that don't even use it too, so it's really up to my patrons as to which direction I end up going.
When you're going from one zone to the next zone on your gliders here, is there any issues at the actual, do you have to actually jump through that transition, or is it just smoothly take the gravity and change the vector pretty easily?
The way that the collision system works in Unity, there are 3 functions. You have collision enter, collision stay, and collision exit. And I'm sorry, not collision. Trigger. On trigger enter, on trigger stay, and on trigger exit. Those are different, very different. Important differentiations between the two, because the collision only deals with collisions, but triggers deal with empty volumes like you're seeing there. And so when it enters that volume or stays in that volume, it's added to a list. And so as long as it's in that list every frame, it determines whether or not it should be used. Yeah, I think that answers your question, doesn't it?
Yeah, I was just wondering if there's any transition issues at that actual point, but I see what you're doing with the triggers there. And just changing the value as it enters the next trigger.
Yep.
And then
And
you're
actually,
deleting it. Are you even bothering to delete anything, or are you just changing the value?
no, it's reparenting it if it's an environmental volume, but if it's only a gravitational volume, then it just adds it to the list. And you can actually have several gravitational volumes that, let's say you're standing in the corner of them, but they all have the same priority. It'll actually combine them.
Yeah.
And then the big strange problem that I ran into with Unity 3D in doing this is actually, if I have an object that has a scale that isn't 1, 1, 1, and I move my character into it, it rescales my character for some reason. Like, it doesn't inverse scale it so it's the same size as it was before it entered it. It's like and it doesn't do it consistently either. I think it's a bug. So, one of my other problems that I've had doing this. Cool. Which one see anything else? Or
So when you watch it through the headset, it's in 3D?
yes, it's in absolute. I mean, it's just like putting on a VR headset for anything else. You got full peripheral and actual head tracking and looking around. And a nice little feature that I found on the asset store that was free was IK head movement. So inverse kinematics using the bone structure for like a character, but telling it where the hand should be, and it figures out where the rest of the arms should be. They have a free controller for the head, so I just kind of toss that in there, and it's also networked. So if you're in VR with someone else, you can see where they're looking. I was expecting more questions out of you.
My main question was about budget.
Of course it was. Okay. Cool. Well, thanks a lot for coming. I appreciate it. And I hope you got something out of it.
So I think there's still pizza and stuff.
Yeah, if you guys are hungry,
You guys are welcome to hang out, chat, whatever. This will be posted on YouTube shortly. Past presentations and all that are on the GameDevMI.com website. And if you guys haven't joined the Discord yet, good Discord to join.
Oh no, where'd they go? Where'd they go? Should I stop the stream?
Yeah.